My name is Peter Egan and I'd like to welcome you to my presentation on cities and communities. I wanted to have a look at how sustainable infrastructure solutions could be implemented on a local scale, with the aim of assisting in reducing our impact on our local environment and assisting the UK Government in meeting its 25-year Environmental Action Plan. I've selected to undertake this by applying sustainable adaptation practices to my home village of Lowestoke to address existing environmental issues. So before we can start looking at new environmental adaptation practices, we need to first understand the problems. We're going to have a look at flooding and pollution data within the village and how recent flooding in January 2020 affected different parts of the village in different ways. We'll then look at suitable areas of sustainable redevelopment and how we can adapt the existing infrastructure to be more sustainable. We'll look at SUDs and stormwater storage, green parking and surface water runoff, living walls and pollution mitigation, and then look how this adapts and changes the biodiversity of the village. Lowestoke is a semi-rural village located in Medway in Kent. It has a population of approximately 1,060 of mixed-race, working-class people. The village dates back to the 1500s, but the majority of the infrastructure in the village is from the 1980s. The village is located very close to Grain Power Station and the port at Grain, which is approximately 1.5 miles to the southeast of the village. The land in Lowestoke gently slopes down to the centre of the village. In fact, you can see from the Environmental Agency's data at the bottom of the screen that it's actually at risk of both surface water and seawater flooding. Now, there's large seawater defences around the Hooth Peninsula which protect the village and have prevented it from seawater flooding for over 40 years. But I've drawn a blue line in the centre of the Google Earth picture to show where flooding is likely within the village. The village is also at risk of large amounts of pollution from local traffic. As can be seen at the AQI table at the bottom of the screen, that actual pollution levels fluctuate throughout the day. This is mainly due to vehicle movements around the village. As you can see in the bottom left-hand corner of the Google image in front of you, there's a red dotted line. This follows the A228, which is the main access route into Grain, where there is a large gas power station and a freight port. HGVs move up this route regularly across the day, putting large amounts of pollution into the village. Also, the yellow dotted line moving across the centre of the screen shows the domestic commuter belt. This is mainly commuted by people moving from All Hallows Village in the west to Hooth Village in the east, and is mainly trafficked early in the morning and in the afternoon as people go to drop children off at school and move back and forth to work. Lowestoke also has a number of critical assets which are vital to life in a rural village, and these are all directly affected by the pollution and flooding within the village. These can be seen as the shops in the centre of the village, which includes the post office and off licence, the doctors within the village, which is along the main flooding route, and the primary school, which is along the main commuter route. As already stated, Lowestoke has great defences from seawater flooding through the defences around the Hooth Peninsula. But in January 2020, the village was actually flooded out by excess rainwater. As shown in section 1, the link between Middlestoke and Lowestoke was flooded out by excess runoff from the local farm fields, which had silted up over the previous months the V-ditches around the village, and the excess water then mounted up in this area, preventing traffic from moving through it. The centre of the village was also heavily flooded, flooding the local village shops and the village car park in the centre of the town. This was caused by surface runoff from around the village, but the village is actually widely greened with lots of open areas, and it was very unexpected to see this amount of water concentrating in the centre of the village. So why did that happen? On inspecting the village after the flooding, it could be clearly seen that actually the infrastructure in the village added to the concentration of water in the centre of the village, then actually dissipating it to the green areas which are plentiful across the village. As can be seen in picture 1, many of the buildings and houses within the village actually channel their rainwater from the roof down into the roads and don't use areas such as soakaways or channels which could deal with the water. The large village car park, as shown in figure 2, is actually raised above the road level and is hard surfaced, channeling any water from it down into the local road, which is slightly raised again above the local shops, flooding them out. Picture 3 shows just one of the many flat roof areas within the village, such as garages, porches. Even the local doctors and village hall have large flat roofs which empty out into the village's roads. As already stated, as shown in figure 4, the centre of the village is actually in a low dip, and that all the roads slope down towards it. These roads are all tarmacked with high curbs along each side, and many of them have brick walls channeling water away from gardens into the road. Picture 5 shows actually the local village green, but this green has a large bund around the edge of it with curbs and grids channeling the water away from the open space, which could absorb the water back into the natural ground, and actually channeling it into the local combined sewer. As you can see in picture 6, across the village is high curbs with grids channeling water into the combined sewer. These grids will get quickly silted up by runoff from the local fields and then channeling water down into the village centre. So now we've identified the issues across the village, how can we use sustainable adaptation processes to change the way the water deals with its water management? As seen in picture 1, a lot of the roads in the village are actually hard surfaces with hard retaining walls and handrails above them with elevated footpaths. This is because throughout history the village has been flooded, and so many of the walkways around the village have been designed to keep people out of the flooded water. So can we change the way we deal with these practices to address the flooding? Well, across Medway there actually is a number of examples of how this can be done. The Horsted Park development in Rochester incorporates lots of suds design within the urban parking connected to tree development and plantation to slow down the movement of water around the park. Also, green and blue developments have adapted a number of the suburban villages in the area to incorporate large plantation swells. So, looking at picture 1, can we change this area? Can we add sustainable eco-grid systems to allow water to drain underneath where park cars are located? Can we adapt the retaining wall to be an earth geotextile combined system to allow plantation with rain harvesting built below it to again accept runoff water from the buildings? This could be connected with the down water pipes from the houses along the road to store rainwater locally and not allow it to run down into the village centre. At the other end of the village, as shown in picture 2, there actually is a number of green areas along the edge of the road, but all of these are raised high above the road and actually channel their excess water straight down into the local streets. They're also connected with high curbs which stop any water in the road existing running back into these green areas. So can we lower them and again incorporate them with rainwater harvesting to capture local runoff on the roads? Again, any parking in this area should be adapted to be eco-grid type systems to allow permeable paving to be used to take water storage below where the vehicles are parked. Also, can we use handrails and existing fence lines as pollution barriers? Can they be adapted with plant growth, moss or other systems to be able to create a barrier between the houses and the road to reduce air pollution? So, adapting the main road throughout the village to include permeable paving and rainwater harvesting is only one of the ways we can deal with flooding. The raised village car park could be removed and replaced with an eco-grid styled permeable surface combined with rainwater harvesting and stormwater storage to allow a 1 in 100 year storm. A great example of this has been shown at the local Horsted Park project in Rochester, where this exact solution has been used as part of the village car park, giving it a combined use of parking for excess outside buildings, but also incorporating stormwater storage. Also, where there is room to incorporate local green areas should be converted to swales, allowing water runoff to be held and filtrated locally, diverting it away from local roads and away from the combined sewer system. Where structural loads allow, flat roofs should be used to convert green roof space to reduce water runoff and increase biodiversity. Local residents can also be encouraged to use water bots to harvest water for their gardens and create rainwater gardens and soakways to deal with roof downpipe water on site. All these solutions together should be able to reduce the amount of water being moved around the village, reducing flooding. Pollution in the village, has already been discussed, has been created by a high amount of traffic to the southeast of the village along the A228 and surge periods through the centre of the village through people moving from All Hallows to Who. We also get a lot of pollution blown into the village from London as southwesterly winds blow across the city. So how can we address some of these problems? Well, the already mentioned plantation, swales and green roofs will help address some of these pollutants by reducing CO2 levels. But can we design in areas as buffers to reduce the amount of pollution going into local gardens and blowing into the school area? Well, presently, to the southeast of the village, there is a sound barrier which was created out of wool compacted into timber framing to reduce the amount of noise from HGVs into local gardens. Could this be incorporated with a green wall constructed from plantation, moss or algae, to be able to reduce the amount of pollutions blowing in from this part of the village? Also, could we, as shown in the bottom right hand corner of the slide, use green living barriers along the edge of the school to stop pollutants blowing into this area? A number of good examples of this have been shown across London and the southeast of England, where green walls have been built as barriers between main roads and cities. A great example of this being undertaken as a study by Sheffield University presently is the Breathe project, where they are building a 60-metre long wall around the edge of a school, incorporating green living walls, local farms to grow products for the school and create a more natural environment for the children to play in. Also, the addition of extra rural footpaths and cycle paths between the villages would greatly reduce the amount of transport required to drop off local school children at the local primary school. This would greatly reduce the amount of pollution passing through and created within the village, but would also create a recreational activity for the school children. So could this adaptive, sustainable and cultural use of different techniques and practices enable us to create a better environment for everyone living in the village while reducing the pollution? Lower Stoke, though being a rural village, is actually lacking in biodiversity, with green spaces and gardens within the village mainly being grassed over and lacking plants. These improvements we are recommending, utilising plantation and swales to transform our existing raised green areas and hard paving, will assist in promoting a more diverse local habitats and ecology, helping bee populations and insects, which will in turn help local farming with pollination of crops. This change in our landscape will also provide a more relaxed environment to assist with de-stressing after dealing with the pressures of modern living for the local population. The benefits of using this change in urban biodiversity has been put to great effect in other UK projects such as Tower Hamlets in London, using plantation and communal areas to promote not just an increase in wild species but an increase in local interaction. I believe this use of holistic, sustainable adaptation processes will enable us as a village to become more sustainable. Following examples such as Horsted Park in Rochester and Tower Hill in London to make a more biodiverse environment within the village, promoting plantation and improving local habitats would be a great way of dealing with our existing problems such as flooding and pollution we presently live with. Bringing more sustainable paving, swales, rain gardens and using the parish council to promote sustainable living using such areas as green roofs and rainwater harvesting within local properties would be a great way of supporting the UK's 25-year environmental plan. I hope you've enjoyed this presentation. If you have any questions, please put them in the chat box below. There's a number of references on the next slide to projects I referred to, and I hope this has given you some food for thought.